Okay, so this video is about the difference between indefinite integrals and definite integrals. Now, we've done these before, okay, so let's just give you an example of one. Here's something nice and simple for you. The integral of 3x squared with respect to x. So just again, remember those symbols. This is the integral symbol, big S, actually stands for sum. Later on you're going to see that integrals are about adding things together, and this tells you that you've got to integrate this variable. Okay, so just the same as in dy dx, it's the same dx. And you remember the simple rule here, all we do is we add 1 to this, so it's 2, so it goes to a 3, so we've got 3x to the 3, and then this new one we now divide by that, so we divide by 3. And then one more thing to remember is we have to add a plus c. Okay, so then obviously that just simplifies to become x to the 3 plus c. And why do we have this c? What's this c for? Well, as if you remember, we said that that c is there because we don't know what that number was before it was differentiated. Remember, this is the opposite process. Okay. Now, a good way to check that we've done this properly is to do just that, differentiate. So, what if we do have y equals x to the 3? dy dx equals, and remember the rule, multiply by the power, 3x, take away 1 from the power. Okay, so that becomes 2. Now what happens to this c here? Well, it's a constant. What happens to a constant when you differentiate it? It turns into 0. So we end up with 3x squared. 3x squared is what we had at the beginning. Okay? So this here is an indefinite integral. Okay? And this is an algebraic expression, something with x in it. That goes in, what comes out? Something with x in. Okay, so remember that indefinite integrals, you've got x in the integral, and then when you've finished, you've also got x in it still. Okay, so that is indefinite. Now we're going to look at definite integrals in the next video.